Welcome in Pharma-info with Shivashish. Today the topic which we are going to deal with is SAR of Benzodiazepines. We all know that benzodiazepines are the class or class of drug, right, which are given for the purpose of treating what? Insomnia, right? And how they are found to be the primary choice in the treatment of insomnia, how they are exerting this kind of action and all, by depressing what? Depressing the central nervous system. Okay, so earlier they were used in insomnia. Later on, as gradually they came to know that it is out of CNS depression, they are developing this kind of action against insomnia. It was further exploited in treating what? In treating psychotic disorders, sometimes given in the treatment of convulsive disorder. At the same time, for the purpose of general anesthesia also, few benzodiazepines are of use, right? Okay. So this is all about the brief about the indications. At the same time, how they are exerting, how they are developing this kind of action and all, right? If we just go in deep, you can find that basically benzodiazepines, if we just try to figure out the pharmacological aspect of benzodiazepines, they are basically a GABA modulator, not mimetic, modulator. So just modulating the functional profile of GABA receptor, and thereby they are just hastening up the process of chloride exchange across the membrane, which eventually leads to what? Hyperpolarization and subsequently CNS depression, right? So this is the way they are exerting their action and all. Now, let me just tell you, let me just waste another 2 to 3 sentences, in dealing with the history of benzodiazepines, right? So long back in the year of 1954, because I'm quite interesting. I'm really quite interested in the history of each and every chemical category of drugs, and that is why in every occasions, right, wherever or whenever I find some time and all, find some opportunity and all, I just try to unveil the mystery lies in the development of the individual respective category of drugs, right? So you can say this is a kind of bad habit, right, which I am bearing with me. So now, SAR of benzodiazepines, let us just tell you the history of benzodiazepines. Actually, long back in the year of 1954, right, an Austrian scientist, he was engaged in making a dye, right? And the dye was, as you know, the dye means there should be, apart from hydrocarbon, there should be a nitrogen. And the dye was nothing but a 6-6 system. That means benzene along with pyrimidine. As a whole, this can be called as quinazoline. So that time the scientist was after making quinazoline, but at the end of the reaction, the product which he got, in that product he found that instead of 6-6 system, there was a formation of 6-7 system. And it is the 6-7 system which in turn been given to what? Been given to a biologist. And after evaluating that 6-7 system, then biologist reported that this particular drug do possess an ability to depress the central nervous system. And from that time onwards, the 6-7 system, which was obtained out of serendipity, it's a very popular name, okay, till now that is there in the market, that particular drug is there in the market, and in the making of benzodiazepine, that particular entity has been considered what? As a template or a lead compound. It is nothing but chlorodiazepoxide. So this came out of luck by chance, out of serendipity. So it is an example of serendipity. And serendipity, we can say one of the method which is being there in traditional drug discovery, right? So as it came out of luck by chance, and that is why we are just calling the invention or the discovery of chlorodiazepoxide is nothing but serendipitous discovery, right? So this is all about the history and all. And what they observed as per the report of 1970s, after that, what all the benzodiazepines came into the market, right? During the year of 1970s, yes, 1970s, okay. In that period, benzodiazepines were found to be the highly prescribed medicines, right? But later on, out of their addictive profile and all, the uses are found to be restricted, right? Okay. Now let us straightway move to the what? Move to the ACR. Okay. For that ACR, as we know that in order to deal with the ACR, right, first and foremost, you need to build what? You need to build a template. Now here, the template is nothing but benzodiazepines, right? Okay. I'm putting here Y, okay, And here we have a X followed by something like this. And here we have a double bond O. And here we have a R. Here R prime. And we have a double bond here. So this is how it looks actually. This is how it looks. Okay. Now, so this is all the template of what? This is the template, right? On the basis of the template only we are going to discuss. Okay. Now let us just put the locate number so that we'll just pick each and every point and discuss and explain. Okay. Explain each and every point. Okay. So this is 1, this one is 2, this one is 3, 4, 5, 6, 7, 8 and 9. Right? So this is how it looks. Now let us deal with one by one. Now as I have mentioned here, this is the first position, right? It should have a nitrogen. It should have a nitrogen because the SAR which we are dealing with, we are discussing is the SAR of what? 1,4-benzodiazepine. 1,4-benzodiazepine. Diaza means 2 nitrogen. Epine means epine for 7-membered heterocycle. Okay, chalo. So this is how the nomenclature stands and all. Okay, the general name stands for it. Why it is benzodiazepine? Benzene, 2 nitrogen, diazepine means diaza, epine means 7-membered, right? That is why. And where exactly they are placed? First and fourth position. Now, coming to the substituent pattern or substitution. Okay. As I said that the ring nitrogen at first position is found to be one of the essential criteria to be kept, right? Now the next thing is that it is the first nitrogen. What kind of substituent that it can accept? Coming to the pattern of R. What they found that if R is found to be a smaller alkyl, activity increases, retains as well as increases. That means insertion of a smaller alkyl group as, what are the options? Like methyl preferentially, like cyclopropyl methyl, sometimes dialkyl aminoethyl, right? So these are the options that are there with us, but basically in most of the times what are the benzodiazepines that are there in the market, they are having this methyl or sometimes it is demethylated as well. Okay? Okay, so these are found to be the substituent pattern at position 1. Now, so we are done with this, the position 1. Now coming to position 2. Okay, it is quite visible for you, that it is clearly visible to you that at position 2 I have kept what? I have kept one carbonyl group, that is C double bond O, right? C double bond O. But if we just look back the structure of chlorodiazepoxide, that means the lead compound, right? In the lead compound there was no carbonyl group. Then why they suddenly thought that better remove the one which is there in the lead compound and insert something which can give us more activity? Yes, it was established that yes, we don't require the one which the chlorodiazepoxide possesses or holding at its second position. If we just try to figure out what is there at second position of chlorodiazepoxide being a lead compound, you can find it is the second carbon that is holding a methyl amino. No longer, for the subsequent benzodiazepines, nowhere you can find that the second position is occupied with a methyl amino. Why? The justification which they give, which they provided us is, it is the chlorodiazepoxide that will undergo what? A metabolic degradation. I should not say degradation. Why? Because we all know that metabolism can be of two types, phase 1 and phase 2. And if we just if we still and we can categorize it in other direction also. Metabolism is found to be constitutive or constructive and destructive, like anabolic and catabolic, right? Okay. If that is the case, here chlorodiazepoxide will undergo or is undergoing what? An anabolic transformation. It is the anabolic transformation of chlorodiazepoxide that leads to the formation of what? That leads to the formation of the primary metabolite or the bioactive metabolite that is called demoxipam. Demoxipam, nordazepam. These are the subsequent metabolite obtained from what? Chlorodiazepoxide. And in each and every, and in that case, while dealing with that particular event, you should find that in the first intermediate which is obtained out of that particular metabolism, there is no methyl amino. That means the chlorodiazepoxide in the process of metabolism, it will undergo oxidative deamination. oxidative deamination, which leads to the removal of this methyl amino from the second position. And that is why in the subsequent series, what they thought that better not to keep any methyl amino. Why? Because methyl amino is not found to be one of the essential things which is supposed to be kept, right? Instead, what they observed that it should be substituted with a carbonyl group so that we can avail we can exploit the chemical property of this oxygen by considering it as a hydrogen bond acceptor. That means it should be kept here. Why? Because this will form hydrogen bond with its corresponding or complementary amino acid, complementary active site residues, right? Okay. Chalo. So this is found to be the thing. That means in order to retain the proper CNS depressant effect, the carbonyl group at second position should be there. Okay. So that means we are done with both the positions, first and second, right? Now coming to the third position. So what they told that insertion of an alkyl. Initially what they observed, while inserting a smaller alkyl like methyl, right, there was no such retention of activity. Activity gradually depletes, right? That means on insertion of a methyl group at position 3 results in no active compound, right? That means I should not say an equally active compound is emerging out of that modification, right? There is no equipotent compound that is developing. That means methyl substitution at third position is not found to be permissible. With that observation, we can conclude that yes, methyl substitution at position 3 is not found to be permissible. Okay. But on the contrary, while replacing methyl, they thought that better instead of methyl, let us just put one or insert one hydroxyl group. The moment they inserted one hydroxyl group, suddenly another observation, okay, came into the picture. What was that? That was insertion of a polar group at position 3 raises the potency by n-fold. That means the moment a hydrophilic substituent or functional group is inserted at third position, which leads to n-fold rise in the potency level. That means potency increases, but though potency increases, but what happened to the duration of action? It decreases. So that means भले ही हम यहाँ पे हाइड्रोक्सिल लाते हैं क्योंकि हमको पोटेंसी ज्यादा मिल रहा है, लेकिन क्या हो रहा है, पोटेंसी तो ज्यादा मिल रहा है, लेकिन क्या हो रहा है, इसका जो ड्यूरेशन ऑफ एक्शन हो रहा है ना वो घटते जा रहा है. So this is the problem, right? This is the problem behind modifying the position 3 of benzodiazepine with a polar substituent. Now the question is why it is affecting the duration of action. That means the moment you are inserting position 3 with a hydroxyl, what happened? You are just providing the entity with a small polar handle, which your system is doing when it is undergoing or when it is trying to modify a particular xenobiotic for the purpose of metabolism, right? We all know metabolism involves 2 steps, phase 1 and phase 2. In phase 1, what we are doing? We are just providing a small polar handle. With the drug itself, we have just provided the small polar handle. Then what is next? Next, only it has to undergo conjugation. That means phase 1 reaction is already done. Once you are introducing the drug itself is holding the polar handle where the conjugation reaction will take place. And that is why it is the duration of action it keeps decreases. Though potency increases, but duration of action decreases. And that is why most of the benzodiazepines are devoid of hydroxyl group at position 3. Right? At position 3. Now, but we have few examples like lorazepam, then temazepam, then oxazepam, right? So these are the examples where you should find hydroxyl group at position 3. Why? Because we have to take the advantage of the potency. That means the condition which demands an increase in potency, not the duration of action. In that case, we'll opt for those drugs which are having hydroxyl groups at position 3, right? Okay, so we are done with this also. Now, okay. Now let us move to the next point, that is position 4. Here also we need a nitrogen. That means we need 2 nitrogens and both are forming a part of the ring system. And that is why the name itself suggests that benzodiazepine, to be more precise and specific, 1,4-benzodiazepine. That means first and fourth position should have nitrogen. Otherwise, you won't call it as what? Benzodiazepines, right? Chalo. So that means here also at position 4, it demands what? it demands the presence of nitrogen. So that means it is the fourth nitrogen. That is also one of the essential criteria that should be placed or that should be kept in order to retain, in order to develop the proper CNS depressant effect, right? Okay. Now let us just move to the position 5, right? Now before moving to the position 5, in between this position 5 and 4, so this is position 5, this is 4, right? In between this position 4 and 5, there is a double bond, right? Okay. Let us just deal with the significance of double bond. Is it really significant? Is it really significant for the proper CNS depressant effect to evolve? Yes. What they observed that shifting the double bond from on either direction, like from here to here or from here to here. That means shifting of double bond or shifting of the unsaturated link in either direction results in depletion or complete loss of activity. That means complete loss of activity or activity decreases the moment you are shifting the double bond from 4,5 to either 3,4 or 5,6, right? So that means it is found to be significant. That means whenever double bond is there, that should occupy the position 4 and 5. Now coming to position 5. Now in the position 5, so it is clearly visible that we have kept one aromatic ring system here, right? And deliberately I have put here Y. Why? Because yes, here they brought the concept of bioisosteric replacement. I'll come to it, but before that, let us just see that what are the pattern, right? What are the pattern of ring system? Is it exclusively of a hydrocarbon, made up of hydrocarbon, or it can be replaced with a heterocycle? Okay. So what they observed that a phenyl at position 5 is found to be one of the cardinal features should be kept. Cardinal feature should be kept inside the compound. That means position 5 should be inserted with what? An aromatic ring system, preferentially a phenyl. Preferentially a phenyl, right? Sometimes what they observe that, so that means if it is phenyl, Y equals to CH. Sometimes what they observe that Y can be a nitrogen. Then also we can retain the activity. That means if the aromatic is substituted with a heteroaromatic, then also activity retains. Here comes the concept or the application of bioisosteric replacement. Say while dealing with bioisosterism, there one under classical bioisosteric replacement, we have already dealt with a particular category called ring equivalent. Okay, so this is an example of this ring equivalent type of bioisosteric replacement. It is also an example of trivalent classical bioisosteric replacement, because here CH is in this form, and N also in this form. So it is an example of trivalent replacement as well, right? This particular application is also found in case of in the discovery of antihistaminic of H1 type, right? Okay. Now someday we'll just take this particular topic also. Okay. Now, so just now what we found, that position 5 should be inserted with a aromatic system. The aromatic should be in most of the times is of phenyl, but sometimes if it is replaced with a pyridyl, then also we can get what? The activity. Activity is CNS depressant activity. Now, and we have an example where maximum we'll find this particular system is benzene. Minimal, in a few occasions you can find the benzene is replaced with pyridine. In case of the example is bromazepam. So bromazepam is an example where the phenyl is not there. Instead of phenyl, the pyridine is there. But still that particular drug is there in the market. That means it is viable in the market. Chalo. Now, so that means as most of the times this aromatic system is found to be phenyl, let us just deal with the phenyl, right? Can the phenyl, or whether the phenyl can afford further substitution? What I mean to say, can we substitute the phenyl which is placed at position 5? What they observe that these are the locations, that means ortho and ortho prime, 2 and 2 prime. These are the locations which can be substituted with an electronegative atom, preferentially halogen. So halogen at 2 as well as 2 prime position of the phenyl, which is found to be a substituent placed at position 5 of benzodiazepine, often elevates the activity. That means CNS depressant effect elevates the moment the ortho as well as ortho prime either of this. It can be mono, it can be di, no problem at all, right? So that means in order to promote, in order to boost, strengthen the activity and all, these are the areas which can be substituted with an electronegative atom. Preferentially halogen, sometimes nitro as well. Electronically rich, right? Halogens are found to be the usual example, right, for electronically rich entity, right? We have with us nitro as well. Nitro as well, because they are functioning in the same way or similar way. Halogen also electron attracting and nitro also electron attracting. I mean to say electron withdrawing, right? Okay, chalo. Now coming to this, is there any other area in this particular phenyl which can also accept the substituent? What they observe that substituting this area, that means the 4' or the 4th position of this phenyl with a substituent irrespective of its nature, that means it may be an electronegative or electropositive, it will affect the activity. There is no elevation, there is depletion in the activity profile. So that means these are the two areas which is favorable towards what? Towards lifting the biological activity. But this is the area which is found to be unfavorable, right? So with that we are done with position 5 and its substituent, and to that substituent whether further substitution is acceptable or not, right? So with that we are done. Now coming to position 6, 8 and 9. Let us just finish it off, then we'll move to the 7, right? Why? Because 6, 8 and 9, what they told that these are the three areas which should be kept unsubstituted. That means these are the areas where you are not supposed to put any kind of substituent for the proper CNS depressant action to grow, right? So that means for the development of proper CNS depressive effect, 6, 8 and 9 of this benzodiazepine should remain unsubstituted. Followed? Now, coming to position 7. I have put here X. What should be the pattern of X? The pattern of X is electronegative atom. So usual, choices are like halogens, like bromine, chlorine, most of the times chlorine, right? Fluorine as well, sometimes NO2. NO2, right? So in case of clonazepam, okay, not in, yes, in case of clonazepam, it is the position 7 which is substituted with a nitro, right? And that time, in case of clonazepam, the same chloro has been shifted to this area, right? So this is the alteration actually. So what they observe or what they told, they are asking us to introduce an electronegative atom at position 7 so that we can elevate the activity. I should not say elevate activity. In order to develop the optimum CNS depressant effect, it is the position 7 which is often been substituted with an electronegative atom. What are the choices? The choices are preferentially halogen, sometimes nitro as well, right? So with that, we are done with what? With that, we are done with the total, more or less the total ACR, right? Okay. Now, so now we are done with the kind of substitution, right, that the benzodiazepine can accept and all, right? So we are done with each and every positions, right? So we are left with few informations, okay? What are those? What they observe that sometimes this benzene, while being replaced with a heteroaromatic system like a thiophene, the example is brotizolam. There also we can find the optimum level of CNS depressant effect. Though they are violating what? They are violating the basic requirement, that is benzodiazepine, okay? But they are applying what? They are applying the concept of what? The ring equivalent. So that means this is the thing. Here you can probably, this is the area where the bromine is there, but we are least concerned about the bromine. We are concerned about this particular modification, right? So here earlier it was benzene, now the same benzene has been replaced with a thiophene. Then also we have got what? Then also we have got the activity. That means benzo, that means the CNS depressant effect prevails the moment you are substituting or rather replacing benzene with some other heteroaromatic as thiophene. The example is brotizolam. Now, brotizolam. Now let us just, we are left with just the final one, right? Fusion with heteroaromatic. Fusion with heteroaromatic. Where exactly? Say, for that, sometimes, let me just keep it phenyl, right? We are done with the informations and all. So most of the times phenyl, sometimes pyridyl, right? Okay. Now, this is the double bond we need. We have a double bond O. Now, let us deal with the fusion. Whether fusion favors the activity or not. Let us see. And let us just see the locations which can accept the fusion, right? Okay, what they observe that removal of this double bond O and fusing this 1, 2, that is first and second position with what? Either imidazole or triazole. If it is imidazole, the example is midazolam. In case of midazolam, this is the area where fluorine is there, right? That means it is complying with the all the criteria which has to be kept in the process of making benzodiazepines as CNS depressant, right? And if it is triazole, like 1 to 4 triazole, in that case the examples are that alprazolam. It's a quite blockbuster drug, I should say. Okay, alprazolam, right? Alprazolam, then triazolam, all are having triazole here. And one more thing is that at the position 1 we have a methyl, right? Both in case of midazolam, that when it is fused with imidazole as well as triazole, in both the cases this is the area which is inserted with the methyl. Okay, what they observe that keeping the methyl here favors what? Hydrophobic interaction, right? Okay, so with that we are done with the overall SAR information of what? Benzodiazepines, right? Okay, now let us just do one thing as usual, what we are doing in our regular videos and all, just in a nutshell, what all we studied. Okay, so first one is, so we have n number of positions and all. First and foremost, we have to highlight those positions and all. First position, we should have a ring nitrogen. The same ring nitrogen should have a substituent, which are found to be smaller alkyl. And what I strongly suggest, the modification, okay, we are providing the modification, the kind of modification that should be there at that position, right? I strongly suggest that after writing the information, you should put one example, like smaller alkyl. As an example, diazepam, okay, like prazepam. And more or less, the smaller alkyl, what are the patterns? Like methyl, like cyclopropyl methyl, right? So these are the patterns, cyclopropyl methyl. Okay, so these are the choices that we are having, right? Likewise, we have just put examples. Now, nitrogen and substituted with a smaller alkyl. Coming to the second position should have a carbonyl group. And here you have a huge number of examples that you can put here. The same examples you can put like diazepam, prazepam, or both are having what? Both are having carbonyl group at position 2. Now coming to the third position, usually you won't find any kind of substituent, right? But the third position, hydroxyl, increase potency, decrease duration of action. And the example is oxazepam, lorazepam, right? Okay, we have ample number of examples. Coming to the position 4 should have a ring nitrogen, right? That should be the prerequisite, right? In between the position 4 and 5, there should be a double bond. Shifting of this double bond from 4,5 to 3,4 leads to decrease or complete the activity totally abolishes, right? Okay, that means you are not transferred the double bond on either direction, right? Okay, now these are all about 4, 5. Now coming to the position 5. At position 5 we have let me just remove it, rub it off. Then position 5, what all we need is a phenyl ring, okay, mostly phenyl ring, and we have another choice, that is pyridyl as well, but most of the times it is phenyl. Example, same diazepam, pyridyl. Example is bromazepam. If it is diazepam, okay, phenyl, okay. Now coming to the substitution of this phenyl, yes, ortho and ortho prime substituted with what? Electronegative atom. Example is midazolam. Example is clonazepam, midazolam, then clonazepam. These are the examples, right? Clonazepam, okay, where you must find at ortho as well as ortho dash position, either of this. Sometimes electronegative atom should be there, right? In case of midazolam it is fluorine, right? In case of clonazepam it is chloro, right? Okay, now coming to this position 6, 8 and 9 should be unsubstituted. Right, for the proper action to grow. Now coming to position 7, yes, 7 should be substituted with an electronegative atom. We have an ample number of examples. The same diazepam can be brought here as an example, right? Now coming to the removal of this benzene ring, it can be replaced with a heteroaromatic system like thiophenol, the example is proteazolam. And now the fusion, where exactly the fusion occurs? The fusion will take place at position 1, 2. With what? Heteroaromatic. That is what the examples are imidazole as well as triazole. If it is imidazole, then the example is midazolam, that is there with us. And midazolam is an example of general anesthesia, right? So for the purpose of general anesthesia also, they are having their application, right? And if it is triazole, then it is triazolam, right? And moreover, it is the position 1 of that fused entity should have a substituent, namely methyl, which favors what? Hydrophobic substitution. So with that, we are done with the complete SAR of benzodiazepines as CNS depressant. If you really like my videos, this video, don't forget to press the like button, okay? But I strongly suggest that apart from this video, please go through the books as well as several videos are there, okay? You just validate this one. You just validate this video that what are the informations which I have kept here, okay? Are they authentic or not, right? In that very process, you can develop the knowledge. It's not simply, like validating my videos and all, my informations and all. It's simply you are just developing a knowledge like anything. So please, thank you for the patience hearing. Thank you very much.